Hello, good morning everyone, and once again, welcome to the electronics world. Our lesson for today is all about computer aided design for electronic works. With this lesson class, it is expected that you, as my avid viewers, will be able to construct an appliance protector device, an electronic device which is a very important tool for the protection of your electronic appliances at home. And to make this project possible, class, it is very necessary for you to equip with the important electronic materials, the electronic equipment, and electronic tools. For the electronic materials class, you need to have this plastic enclosure wherein the dimension is 2 inches thick, 3 inches wide, and 5 inches long, with the AC cord, the AC socket, the relay switch, a PCB or printed circuit board, and the other electronic materials or electronic components to make this project complete. Together with the other test instruments, of course, the analog multitester, the digital multitester, and this multifunctional tester, which are very important for the measurement of the voltages, resistances, and capacitances. Also, to determine also their functionality before the electronic components are mounted and soldered on this printed circuit board. Of course, we need to have these electronic tools, the solder sucker, together with the soldering iron with a soldering stand. See to it that the soldering iron that we are going to use is 30 to 40 watts. This is 40 watts, which is sufficient or excellent for the soldering of the solder, which is 60 by 40%, 60% tin and 40% lead. Or if possible, we need to have also this flux, a soldering paste, which is an additional flux applied to a surface of the PCB to remove the foreign substance that will hinder the adherence of the melted solder on this copper clad. Of course, we need to have this mini electric drill equipped with drill bit, which is 1/32, and we need to have also this 1/16 for drilling holes for the terminals of the electronic components. We need to have this 1/16 also diameter size of drill bit, because for the relay switch there is a bigger diameter size of the terminals, no, as well as the terminals also of this AC cord. Of course, we need to have this long nose plier and the side cutter plier. For the etching process, the etching, by the way, class, is the process of removing the unwanted portion of the copper clad. We have here a PCB composing of an insulator material and a conductor material. An insulator material is usually made of a flame retardant epoxy resin with a composite of fiberglass woven. We have here the substrate or the base or the insulator material, which is usually made of flame retardant. We call it epoxy resin composite with fiberglass woven. So if we try to measure the continuity or the resistance, it is usually infinity. There is no deflection of the pointer. That would mean that it is very high resistance and it is very excellent use as a substrate or a base of the copper clad. We have here the copper clad or the copper foil, which is a very thin foil of copper, which is laminated on the surface of the substrate by means of heat. It is actually a conductor because it is a copper material. if we are going to test it using ohmmeter, it is very low resistance, 0 ohm. It is a very good conductor, which will serve as a wiring for the electronic components. No? Again and again, this is a copper clad or copper foil. It is a very thin sheet of copper which is laminated on top of this insulator material or the substrate. It is usually made of epoxy resin composite with fiberglass webbing. Okay? Then, what else, class? Of course, we need to have this ferric chloride solution. It is a corrosive and acidic chemical compound. It is poisonous, class. We need to have this because it is used to remove the unwanted portion of the copper clad. We need to have a plastic enclosure to pour or put this. At first, we have to shake first this bottle to totally mix the ferric chloride solution. Okay, we need to put it in a plastic container just like this. Of course, we need to have a plastic basin for the water because after etching, we need to wash it using this water. Of course, if you have available cloth, of course, you need a cloth. Okay, just like that. What else, class? Of course, we need this lamp to provide sufficient light for the work. We need to have also this magnifying glass. If your eyes is foggy, for you to read the numerical code or the value written on the surface of this material or of these electronic components, that can be magnified using this magnifying glass. So, magnifying glass is a very important tool also to make your eyes clearer to see and to read the numerical code, especially the color codes of the resistors. And most importantly, we need to have a laptop, of course. Because as what I have said a while ago, that our lesson will be all about computer ED design for electronic works. Because before we proceed to the project making, we need to design first an schematic diagram. We need to have this electronic software, which is the Express schematic. It is just like this. Okay? You are going to draw an schematic diagram here. Just like this. Schematic diagram, we can draw and delineate schematic circuit using this Express schematic. It is a computer ED design. We need to sketch first a diagram before we will make a PCB layout. A PCB layout actually is just a wiring of the components we have here. This is just an example of PCB layout. So, we will use the PCB Express or Express PCB for making a layout for your components. Just like this. Express schematic and Express PCB are the two computer design electronic software used for designing a PCB for us to, of course, assemble the project. Okay. Alright, class, let us now come to the creation of schematic diagram for your appliance protector circuit. Let us open these icons here, the two electronic softwares, which are the so-called computer ED design software. We have to first click this Express schematic to make an schematic diagram for your appliance protector device. Of course, at the top are the Express schematic toolbars, also at the left side. This will be used in the making of the schematic diagram. At first, you need to have the necessary components. So, just click this one here for the selection of the components. No? For the selection of your components. Actually, it is the library components. So, at first, we need to have the diodes. Okay, look for the diodes. We have here the list of the electronic component symbols. Okay, look for the diodes. Okay, diode. Okay, where are the diodes here? Okay, we have here the semiconductor device. Diode belongs to the semiconductor. Look for the S under semiconductor. So, diode. If there are, okay, diode. Zener diode. Of course, we need one zener diode. Just click diode zener. Then, insert into schematic. Okay, then you may right click here of your mouse. Then, component manager. And look for the diode which is this one. For the rectifier diodes. No? Rectifier diodes. Okay, insert. Okay, we have here. Where is the diode here? So, wala. So, you may click your mouse. Right click. Again, component manager. Look for the diode. Semiconductor again. Diode. Okay, diode. Okay, this one here. Okay, we have here. Insert into schematic. Okay, we have here. The diode. This one, diode. Zener diode here. Symbol is like this. Then, we need 5 diodes actually. Because, for the rectifier diodes, we have 4. And another diode for serve as a voltage spike controller. So, we have to click this to make it blue. Then, press the control together with the C and V. So, since we need, okay, there are 2 rectifiers already. We need additional 3. Just click CV and making it 4. There are already 4 diodes here. For the rectifier diodes or for the rectifier circuits, we need additional 1. So just shade it and press the control button together with the CB. So there are already 5 rectifier diodes and 1 zener diode. Also, we need resistors. How many resistors in an appliance protector circuit? I think there are 5 resistors. So, just right click here and press this component manager. Okay? Then look for the resistor. Resistor QRS. Where is the resistor here? QRS. Resistor. Look for the, we have here the resistors. Okay, we have here the passive. Under passive, because resistor, capacitor, inductors belong to passive, whereas active are the diodes, transistors, no? ACR, triac, diac. So, press this resistor. Then, insert into schematic. So, we have here already here. Where is the resistor? Click. Let us try to separate here the resistor. Oh, we cannot separate. Okay, try. Another right click of your mouse. Then insert into schematic resistor. Okay, we have already here. So we need to delete this. Shade it and press the delete. So we lack 1 diode. So just shade this by pressing the left click. You can have the left click. Then press control, long press, then C and V to have. Okay, we have already 4 diodes here, 5 rectifier diodes with 1 zener diode and 1 resistor. We need 5 resistors, of course. We need to press this 4 times. CV, 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 CV. Okay, let us try if there are already how many resistors we have here? So we have already 5 resistors, okay? We have already 5 resistors here. Then we need to have capacitors. We need to have capacitors. One polarized capacitor. There are 2 polarized capacitors. So just click the mouse, right click, then press this component manager. Then look for the passive capacitor we have here. There are actually 1 polarized, 1 non-polarized. There are 2 non-polarized capacitors. So we need to have this capacitor, non-polarized. Insert into schematic. Okay, we have already here. Then we need to, while it is still at the shaded condition, we need to press this control, long press. Then letter C, letter B. So there are already capacitors non-polarized. Okay. Then there are also electrolytic capacitors polarized. There are 2. So again, right click of your mouse, then press the component manager and look for the passive, okay, passive polarized capacitor here. Okay. Click, left click, then insert into schematic. So we need to have 2 electrolytic capacitors. That's why it is press, long press for the control, CV, CV. So there are already 2 polarized electrolytic capacitor. Then we need to have the IC, LM555. So for short version, just click this right button and press this component manager. Then look for the IC. Try to have the semiconductor. Where is the semiconductor here? Okay. Anyway, we have here already. We look for the IC. IC, which is the LM555. LM555. Okay, okay. At first, we have the available relay switch, SPDT. Let us try to have first this one. Okay, insert. Then we have here the relay switch, which is this one actually. We have here the relay switch. No? There are actually okay, there are 5 terminals over here. 5 terminals, no? Okay. There are 5 terminals. We have here the actual spare part of a relay switch. It is a single pole double throw switch, relay switch. This portion here, this one and this one, these 2 terminals here, this terminal and this terminal are the terminals of the coil over here. This one, these terminals. Okay. Terminal 1, terminal 2, it is non-polarized. They can be inverted. This one here, this terminal here, and this terminal here are these 2 terminals. Okay. We have these 2 terminals. This terminal here and here. Okay. The terminals of the coils which are here. This one. Okay. Then these 3 terminals here are for the switches. The center terminal, a terminal between these terminals of the coil is the center. This one here. Then terminal 4 and terminal 5. This terminal here, these 2 terminals is normally closed. So if we are going to test it using when you are looking for the two terminals which are normally closed, the center one is over here. These two terminals now are normally closed. It is actually here. This one, the center, and the NC terminal over here, normally closed. This NO or normally open is actually over here. There is no deflection of pointer over here. There is no deflection of pointer of your ohmmeter. Meaning to say normally open NO. This terminal is normally open. This portion here. Okay, but this one is normally closed. Okay, so we call this relay switch as single pole double throw. No, once it is turned on, the terminal pole will be transferred this terminal. No, the normally open a while ago will be normally closed na. It is closed due to the electrical current that is submitted to the coil, which will produce magnetic field to change the contact of the pole from normally open to closed. Okay? Let us look for the IC LM555. Just right click of your mouse, then go to component manager, left click. Then if you find it difficult for you to look for the LM555, just encode find for the 555. Then find first. So we have here, automatically it goes to the LM555. So just click this one and it appears the schematic symbol of the 555 timer. So insert it into schematic. That's why we have here. Okay. So we need to have the lead also, the light emitting diode. So again, right click of your mouse. Then go to component manager, left click. Then go to semiconductor. Okay, semiconductor. We have here the LED. Okay, the LED, light emitting diode. Click, insert into schematic. So you need to have two light emitting diodes. So long press for the control or CTRL. Then press C and V. So there are already two diodes here. Okay. Then of course we need the common or the ground. So look for the ground symbol. If it is very hard for you to locate for the ground here, just encode find, no? Then ground. So it appears now the ground. Find first, click. Or cannot be find including ground. So probably we need to have the return ground, return ground, return ground, return ground if it has available. Return ground. Okay, cannot be found. So let us look for the ground here. Symbol, ground, symbol. Motor, speaker. Where is the ground symbol here? Ground symbol. Look for the ground symbol. B, library symbol. Okay, we have here. Go to library symbol. And it appears the power ground. Okay, power ground. Okay, we have here. There is no chassis nor earth ground here. The return ground is the most commonly used ground symbol. So insert into schematic. Then click at least 10. Long press control or CTRL, then CV, just like that. How many ground symbols we have here? Ground symbols that we have here. ground symbols that we have here. Ground symbol. Ground symbol. Okay. There are many symbols for the ground. Okay. We'll now proceed to transfer I. Okay. Transfer this one over here. Okay. So, at first, you need a resistor. Transfer it here. And one capacitor. Non-polarized capacitor over here. So, to rotate this, one rotation, okay, it goes like that. No? Okay. 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 Capacitor here, then resistor at top. Okay. Okay. Then, we have here a voltage dropper and a decharger resistor. They are actually connected. So, to connect them, use this toolbar here. Okay. Then, connect. Left click. Then, left click again. To cut it, right click. Okay. Then, proceed here. Left click. Then, left click. To cut this one, right click. Then, of course, it should be connected to the AC power line. Left click. Left click. Then, to cut it, right click. So, on the other hand, we have a resistor also here. Right click, left click. Left click again. Then, left click. To cut it, right click. Then, we need to connect a resistor. So, proceed to arrow cursor. Before you proceed to the next component, resistor, just press to make it shaded component. Then, transfer it here. So, rotate. Use this toolbar. Okay, to rotate. 45 degrees. Okay, we have here. Then, to connect a diode, we have to use this tracker. Click, left click, then drag. Drag. Then, right click. Then, proceed here. Right click. To cut it, right click. Then, we have here, left click. Then, left click. Then, left click. To cut it, right click. Then, we need it 4 diodes. So, you cannot proceed by picking the diodes here without going back to the cursor or to the arrow. So, we need these 2 diodes again. Shade it to the 2. Then, another 2 diodes here. Okay, another diode here. Okay. Actually, there are 4 diodes. So, diode 1, rotate twice. Okay. Okay. Connect these two. Oh no, proceed first to the another set of diodes. Rotate this. Okay, anode. Then this one here, proceed here. Cathode. Okay. So, proceed to the struck press or then left click. Drag to trace or to track. Then click. Then click. Then cut, right click. Then proceed here. Left click. Then left click. Then to cut it, right click. Then proceed here to connect this one. Right click. Right click. Okay. Then also here, connect this one. Left click. Left click. Cut. Right click. Left click. Left click. To cut it, right click. Okay. These 4 diodes now serve as a bridge rectifier. They are in a bridge configuration. Then, this is actually connected to the negative side. So, left click. Left click. Cut it. Proceed to the cursor or arrow. Then bring this one, press to make it shaded. Then put it ground here. Then this one actually is the positive side. Okay. We have here. Proceed here, back. Then, right cursor. Move this one to this side here. And bring this IC over here. Okay. The positive side of your LM555. Okay. Okay. Proceed it here. Okay. So, pin number 8 and pin number 4 are actually connected together. So, proceed here to this toolbar for tracking. You have here pin number 4. Then, left click. Then, left click. To cut it, right click. Okay. Then, connect here the electrolytic capacitor again. Proceed to the arrow. Then, the polarized capacitor is over here. The polarized capacitor is over here. Bring this one here. Bring this one here. Okay. That is the capacitor. Then we have here a Zener diode. Okay. Zener diode. Okay, just like that. Actually, this capacitor and Zener diode are connected to the ground. So, we need to connect this one here. Okay. Then this one here, connected to the ground. Remember that this ground symbol, return ground, are connected together. No, this is the way how we make an schematic diagram using the express schematic. It is a computer aided design or CAD. This is now the complete schematic diagram of an appliance protector using the express schematic. After delineating or sketching these diagrams for appliance protector device, we'll now proceed to the next electronic software, which is the Proceed. Cancel. Then, we need to cancel this. We'll now proceed to the next CAD or Express PCB software. We have here the Express PCB for making a layout. Okay. We're going to use this electronic software, which is the Express PCB. No? Again, another toolbars for Express PCB. Almost same with Express Schematic. We call this software as Express PCB for making a layout for your PCB. Okay. This corner here, which is the unshaded square, because there are square also here which are shaded. This means that this is now the origin of the coordinates. We have here the x coordinate and this y coordinate. The x coordinate is the length of your PCB or printed circuit board, and we have here the width of this PCB. So, if your cursor is positioned over here, at the bottom here, if we will put this cursor or the arrow over here, that measures the length of the x coordinate. And it is actually 3.8 inches. If you will put this arrow over here, that measures the y coordinate, and that is now the height of the PCB. And it is actually the 2.5 inches. Actually, we can still extend this length of the x coordinate. Just left click over here, then put it here. No? We can actually increase the x coordinate up to 30 inches. And also over here. Okay? Just like that. We can also increase the width at the y coordinate. No? Just like that. Then just like that. Okay. So, no. Okay. Proceed to. Okay. Because the size of our PCB is, we are going to have this. How did we get this size of our PCB? No, it is actually 2.5 by 3.5 inches. 2.5 by 3.5 inches. So, at first, to get the 3.5, double click over here. Left click of your mouse, double click, and it appears here. So, we need to change this one to 5. Back, then change it to 5. The length at the x coordinate is 3.5 inches. Then, okay. Okay. Then proceed here. At the y coordinate, double click. Then we have to, we have already the available 2.5 here. What you are going to do is to click the OK. Okay. Then, double click again over here. Double click. Then this is actually 3.5. And over here is 2.5 already. That is the length, the height, and the length at the x coordinate. So just click, double click here. Okay. That is now the 3.5 and the 2.5. We have here actually the size, the dimension of our PCB. No? Okay. The dimension of our PCB. Okay. It goes like that. Okay. So, what are the necessary components? So, based from our diagram here, where is the diagram? We have here. Okay. Based from our schematic diagram, we are going to follow this diagram actually, as well as their values, no? There are actually 1, 2, 3, 4, 5, 6, 7. There are 8 diodes, 5 rectifier diodes with 1 xenon diode and 2 light emitting diodes. So, based from the schematic diagram, so let us have here. So, you must be looking for the component. You may just click the mouse, right click, and go to component manager. Look for the diode. Okay? Look for the semiconductor probably. Semiconductor. We have here the diodes. We need to have 1N4007. These are the specification rating for our rectifier diodes, as well as the voltage spike controller. So, click this one here and insert component into PCB. We need to have 5, this one here. While it is still shaded, just long press for the CTRL, then 4 times. CV, 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 CV. So, there are already 4 diodes here, rectifier diodes, no? Okay. 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 Then, we need to have resistors. How many resistors do we have here? 1/2 watt? 1, 2, 3, 4. There are 1, 2, 3, 4. There are 4 resistors basing the schematic diagram over here, di ba? 1, 2, 3, 4. There are 4 resistors. There are 3 pieces of 1/2 watt resistors and 1 2 watt resistors. Okay? See here? Okay, we have here. So we need to have the resistor. So right click again, go to component manager, then look for the resistors. Where are the resistors? Okay, we have here the resistors. We need to have 0.5 watts. 0.5 watts, okay? 0.5 watts. There are 3 resistors, 0.5 watts. So while it is still at the shaded condition, so press CTRL with CVCV so that you can have 3 pieces of 1/2 watt resistor. Then, right click again, go to component manager, and look for the 1 watt or 2 watts because we need to have 2 watts resistor. So we have here, resistor 2 watts. Okay, press, then insert, and we have actually here, no? Then, proceed to the capacitor, electrolytic. Right click again, then component manager, capacitors. We need to have the capacitors here. It is actually radial, just like that. No? Radial, not axial. So radial because we have 2 pieces of electrolytic capacitor. Because if it is axial, it goes like that. No, we need to have a radial capacitors. Radial, smaller one. Okay, we have here, smaller one. Then insert. Then proceed here, again, component manager, for a bigger capacitor. Bigger capacitor, over here. Okay, insert. Okay, we have already here. Then we need to have a non-polarized capacitor, mylar. We need to have 1. So, right click, component manager, then capacitor. So, we need to have this over here, the smallest one, then next to the smaller, just like this. Insert. Then, okay. Then, for a voltage dropper, it is a very big capacitor. So, component manager, proceed to the biggest probably. Oh, we can have this one. Okay, bigger one. For the voltage dropper, insert component into the PCB. Just like that. Then what else? We need 1 Zener diode. No? You don't have yet the Zener diode. Right click again. Then component manager. Diode. Where is diode here? Diode. Okay, diode, we're here. Diode Zener. 1 watt. Because we are not using 1/2 watt, but 1 watt. Click. Then insert into PCB. Then what else? Right click again. Proceed to component manager. Then the light emitting diode. Okay. Light emitting diode. If we have available light emitting diode here. Okay, light emitting diode. Where is the light emitting diode over here? Light emitting diode. Where is the light emitting diode? LED. LED diode. If you can find LED, just encode here LED. LED. B. Okay, we have here the LED. Okay, we have here the LED. We are looking for the bigger one. because this is 1 inch, we need to have 1.75. Then we need 2 LEDs. So, while it is shaded, just click Ctrl CV to make 2 light emitting diodes. Okay? We are using a jumbo LED here. Jumbo LED. Then, of course, we need to have an 8-pins 555 timer IC. So, right-click again. Proceed here. Then, pins, 8 pins. We have here the dual inline package. We need 8 pins over here because 555 timer IC is composed of 2 sides, 4 pins each side, making it all 8 pins. So, insert. Okay, we have here. Then, proceed to the position. Look for the most appropriate position of the components. We need to have this capacitor, diba? We have here the bigger capacitor. Put it here. Because based from the diagram over here, capacitor, a bigger capacitor non-polarized and a resistor are connected in parallel. So, we proceed here. No. Okay, we have here. So, while it is shaded, just rotate. Okay. Then, 1 resistor, 1 mega ohm, put it here. Then, put it here. Then, while it is shaded, you have to rotate also here, just like that. No? The resistor must be here, and the capacitor must be here. Okay. Okay. Then, the biggest resistor is over here. Just click it. Okay, just like that. Okay. Then, the 4 diodes are over here. So, shade the 4 diodes and rotate it. Rotate. Okay. So, this diode, you have to rotate this diode. Oh, no. Only 1. Okay, just like that. Okay, that must be the position, no? Okay. Then, the next diode is over here. Shade it. Then, put it here. Then, this diode should be rotate twice. Okay. Okay. Then, diode is put here. By the way, this diode should be inverted twice. 1, 2. Okay. Make it align. Make it align. Okay. Shade it to simultaneously move the resistors. Looking for the correct distances. You have here. Okay. It goes like that. Then proceed here. Okay. Then what is next? You may put this resistor, this one, over here. Shade it. Looking for the best and possible position. Then rotate this. Okay, just like that. Then this polarized bigger or smaller capacitor electrolytic. Put it here. Put it here. Okay. Then the biggest capacitor is over here. Shade it. Just like that. Then zener diode should be, let us have first the, transfer this one here. Okay. Put this zener diode over here. Then rotate this one twice. 1, 2. This must be the correct position of the 555 timer IC. Okay. Then the zener diode. Where is the zener diode here? Okay, probably this one. You can use this one as a zener diode. Okay. Just like this. Okay. Rotate this one twice. 1, 2. The cathode is at the bottom. Okay. Then put resistor here. at this point. Okay, resistor. Then, the two light emitting diodes is over here. You may put it here, over here. Then, another diode, light emitting diode is over here. Then, the resistor as a series dropping resistor for the diode, light emitting diode is over here. Move it here. Then another resistor. We lack one resistor, so therefore shade it by putting the cursor over here and left click. Then press the CTRL long press, then CV to add additional resistor. Put it here. Okay. Over here. Then move this lighting diode over here. Okay. Then this rectifier diode, which is used as a voltage spike controller, must be put here because we need to have a relay switch over here. So let us make this one closer. Shade the three components so that they can be moved at the same time. Then again, just like that. Then putting them together here so that there is a bigger space for the relay switch over here. Actually, unfortunately, we don't have available relay switch in the component manager. We can only make using the customized, no? You can use, actually, you can make a line over here using this yellow color if there is yellow available here. Okay, just like this. Then over here for the relay switch, for the relay switch, for the relay switch. Okay. Okay, for the relay switch. Then we can make a terminal for this. It should be like this. The center is over here. Then another. Okay. Okay. Then additional terminals here for the relay switch. Just like that. Okay. Now let us come. When the complete components are already here, or we can still make for the AC socket over here. We can make an AC socket over here. AC socket. Okay. We can make two terminals over here. Two terminals over here. Okay, just like that. Okay? Then we can move actually, because there is a bigger space over here. Save them together and move. Okay. We'll now proceed to the connecting of the components. Actually, the components that we put inside this PCB are the actual physical size of the components. We have nothing to worry about it. So, let us click this tracker here. When you look or when you plan for tracing a circuit, let us. This is now the size of the PCB track. We may use 60. It goes like this. These two components actually are connected together. No. Let us use red color. No. Red color. Okay, we have here. Just like that. Okay. Then, right click. Then, left click again. Left click again. Left click, cut. Okay? Then, of course, this voltage, the charger and voltage dropper are connected together. They are connected in parallel, and they are connected to the AC power line over here. AC power line over here. To the AC socket. Okay? Then there is a resistor also is connected to the AC power line over here. So, it should be like this. We can actually increase the width of the track over here by changing it to 100. So it goes like this. Okay, just like that. The bigger the width of the track, the lower the resistance. The lower the resistance is, there is a large amount of current that will flow compared to a smaller or narrower width of the copper clad. No? Also over here, we can increase the width over here, over here. Okay. Then, these two diodes, the anode and the cathode are connected together. Then, left click, then right click to cut. Should be connected here. Diba? Okay. We will make it bigger. Okay. 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 Then, these two diodes are also connected together and connect it here. If we have to base the schematic diagram we have here. Diba? The two components are connected to the AC power line. The resistor terminal is connected to the AC power line. Then, this portion here is connected to the anode and cathode of the diode. Whereas the resistor here, yung bigger resistor, is connected over here. Okay? So, proceed over here. Okay. Then, this cathode is connected to the cathode over here. Okay? Cathode are connected to the positive side of your electrolytic capacitor over here. Okay? Okay. Okay. Then, of course, this one also is connected to the positive side of your capacitor. And this one is connected to the negative side. The negative side here, the negative side, actually, where is the negative side? This negative side here should be connected to pin number 7 and pin number 1. So it is much bigger. So we can actually change it to, we can use 50, smaller one. Because pin number 1 and pin number 7 over here are connected actually, and they are connected to the negative side. So therefore, connect it to the two anodes of the diode. No? Connect it to the two anodes of the diode. No? Then, the positive side, pin number 8, the pin number 8 is over here, is connected to the positive side over here. And pin number 4, diba? Pin number 4 and pin number 8 are connected together. Base the diagram over here. We have here, the pin number 8 and pin number 4 are connected, and they are connected to the positive side. So therefore, we have here, pin number 4 and pin number 8. So pin number 4 is over here. Pin number 4 is connected over here. If you think it is closer to this terminal number 5, so we can erase that arrow, then click and delete. Also here, delete, because it may cause shorting to this terminal number 5 of your IC. So, you can actually change it. So, therefore, this pin number go to the track. The pin number 4 is connected to the positive side over here. So, if you think this terminal resistor is much closer to this terminal, go to the arrow, then move this one farther. It goes like that. So, the advantage of making the track wider, change it to 100 for example, we can make it this one wider. The advantage of making the track wider is for economical purpose. Because the shaded one can't be melted by the etching process. This can be melted, the red color. They are the wanted portion of the copper clad. So, what is melted by this chemical ferric chloride solution are the unshaded. Without track, this portion here will be melted by the ferric chloride solution. The purpose of making this one wider is that only lesser amount of the copper clad are melted, and you can still use the ferric chloride solution for many times. Because if there is a bigger space to be melted, the ferric chloride solution will become sticky and it is no longer effective. Again, the wider the track, the lower the resistance, the higher the current. But the bigger the track, the closer the copper clad. There are two paths over here. Once they are too close to each other, it is critical to a radio frequency circuit. So it is impractical. It is not applicable by making a wider copper clad when your circuit is a radio frequency circuit. No? The radio frequency circuit is very sensitive to stray capacitance. Remember that capacitors are made of two conductors separated by insulator. So the insulator that is used as a separator of the two conductors here is the air. No? So therefore, if we put it closer to each other, there is a so-called existing capacitance. We call it stray capacitance. It is not included in the design of the circuit. So there is a problem when it comes to power supply circuit. There is a problem with power supply circuit because there is no radio frequency actually here. The frequency being processed by the power supply is only 60 Hz. So 60 Hz is not susceptible to closure of two conductors that will constitute capacitance. Usually 1 to 2 picofarad will be constituted by the two conductors or two copper clads which are placed closer to each other. So we have heard the final design of our PCB. By the way, how these R1, C1, C2 are made? So we can use this alphabet A here. Then you can encode the R1 for example. R or capital letter R, shift R, then 1. Then put it here. Okay, let us first erase. We are using red color. So delete. Go back again to letter A here. We have already R1 here. Just press this yellow so that then left click R1. No? If you want to erase here, okay, shaded, you can delete that. If there is no available R1 here, just put it here. Okay. But this is now the portion of your screw. No? The screw for fastening the PCB to your enclosure. Actually, I am using this one. No? I am using this one here. Okay. Put it here. Okay. Arrow over here. Okay. This one here. Okay, just like that. It is yellow color, so therefore, we have to use this one here to make it gone. No? You can put it here. Okay. Okay, that's all, class.